All right, ladies and gentlemen, we're going to talk about solving problems with dilution or diluting things. And let me get to a pen that we can see the ink. So dilutions. So what we're doing is we're taking a certain volume of our stock solution. So we need volume of stock solution. This is abbreviation for solution, and then we need the molar concentration, the molarity. I'm just going to say concentration because you can use any of the concentration units with this, and that's going to equal. If you multiply those together, that's going to be equals moles of our solute. But then again, our moles of solute that we're going to dilute, that's in our final solution, is equal to the final volume that we dilute to of diluted solution, and also the final concentration. And so what we do is we call M1 is our initial concentration of our stock concentration. V1 is our volume of solution that we take. So we're taking this solution. And that equals to V2, which is our final total solution volume. And M2 is our final concentration of our diluted solution. So that's M1 V1 is equal to M2 V2. And sometimes you may see it as MI VI is equal to MF VF. So, something to that degree. But basically, we're multiplying the first concentration times the volume that we take out. This is chemistry, not physics. And then that's equal to the product of our diluted stock solution concentration and our final volume. And so basically this is moles we take out and final moles we have. They're equal to each other. And this is what we mean by that equation. So again, we're just looking at M1 V1 is equal to M2 V2. And now if both concentrations are the same unit and the volumes are the same unit, you don't need to do any conversions. So if you have milliliters for both, you can use liters again. If you have milliliters, you can use milliliters. If you have molality with an L, you can use, your final answer should be molality. So this is what we're trying to work on with it, stress with this type of solving. And it's just this simple equation. And most people have this in their heads. So M1 V1 is equal to M2 V2. Now how are we going to do this for this type of equation? So we have M1 V1 is equal to M2 V2. And all these different types of problems, we're going to have 3 out of 4 variables. So how much does a concentration can be made by diluting? So here's a verb. So we're taking 450 mils of this concentration. And so this is the problem with these problems, is understanding what's occurring. And it's the wording that's going to drive you guys nuts. And there's so many ways to word this, so you got to realize what's first and what more concentration and volume go together, and are they initial or final. So how much? So we're looking for a volume of solution, because now we have a concentration. So here's one concentration. So this is concentration. We don't know if it's first or second. Here is a volume. We don't know if it's first or second. And here's another concentration. And these two actually go together. It's diluting, say, it's 450 milliliters of a 9 molar solution. So since this is a higher concentration, so M1 is 9.0 molar. And this is what I want to stress. The highest concentration is usually M1. Since the verbiage here, by diluting 450 milliliters. So we're taking 450 milliliters, adding more to it. This is what this term means, diluting. It means we're adding more water or solvent to 450 milliliters that we already have. So my V1 is going to be 450 milliliters. That is how this is interpreted. And now let's go here. We know this is M2, our final concentration, 0.075. Now we know this is our final concentration because we already have our initial, and this one's lower than that. So makes kind of sense. Now V2 is what we're looking for. We don't have another volume. So M1 V1 is equal to M2 V2. We're looking for V2. So M1 V1 divided by M2 is equal to V2. Now with this equation, all we do is divide both sides by M2 to isolate V2. Molarity times volume divided by molarity. Molarity cancels, and we end up with V1. So let's go ahead and do the multiplication. Let's put the numbers in. 9.0 times V1, 450 milliliters. We're going to keep them, we're not going to change the unit, divided by 0.075. And that should give us my final volume, and that's going to be in milliliters. So get your calculator out, ladies and gentlemen, and we're going to take 9 times 450. Let me get to my calculator. 9 times 450, we get 4,050. Then we divide by 0.075, and we're going to get a big number. We're going to get a number that is going to be 54,000 milliliters, or 54 liters. If you put this down, I'll count it right. So this is how this works. All we're doing, this is what we're doing for those dilution problems. You got 10 to work on. Have a good luck with this. If you have any questions, let me know.